So this is 6.4 B as in boy, elementary algebra, still doing special factoring patterns. And we are on example number 8. And before we get started with that, just as there are certain binomials, your book says, bottom of page 411, whose terms are both perfect squares, we can also factor binomials whose terms are both perfect cubes. So a number cubed plus a number cubed, or a letter, that equals, and this is a solution that you don't figure out, you just learn it. Memorize it, put it in your notes. So I'm just going to put down the formula, and then we'll do one that shows using the formula. And I have kind of a strange way of teaching this, but to me it's what makes sense. So that's why I do it. Alright, so let's look at one. Let's jump up to example 10. Okay, there's my first term, matches with that. There's my second term, matches with that. First thing we want to do is make that into something cubed. Okay, so now I've got something cubed. Alright, now that it's in the correct format, where I've got one letter cubed plus another cubed, just like this, I'm going to use this then to solve it. So it says a plus b, or basically your first term plus your second term. Don't worry about the exponents. First term plus the second term. Okay, now this is the part that goes a little bit weird. What I do is once I have this, I get rid of that. I promise it will confuse you if you don't get rid of all that. Just use this in order to solve the rest of it. So what we're going to do is we're going to use this to give me everything that goes here, just like I would have used this to give me everything in here. So what does it say? It says take the first term and square it. There's the first term, so I'm going to square it. There's the first term, I'm going to square it. Then it says minus. Then it says AB. It says take this times this. So my AB over there is this times this. Plus, last term squared. So I'm going to take that 3 and square it. Okay? I'll let you look at that for a second. And I am done. That's all there is to it. Okay? What it does by getting rid of this is it keeps you looking at that, keeps you from looking at the y cubed and the 3 cubed and trying to figure all that out. Do I square the y cubed or what? You know, so it just, to me, it just makes things from being all goofy. Okay, so let me see what I can get rid of. And we'll try one more here. Let me put the formula back up here, so I'm going to pause. So let's look at t cubed plus 1 over 27. Alright, so again, first thing we're going to do is rewrite this. Something times something times something is going to give me 1 over 27. Well, I know that something is a 1 over something times 1 over times 1 over, because 1 times 1 times 1 will give me that 1 on top. So the bottom, what number multiplied by itself 3 times will give me 27. 3 times 3 is 9, times 3 is 27. So I can write this as 1/3 cubed. Alright, that's always the first step, is to make sure that you have a cubed both here and here. Now, I'm going to, again, put it in this format. So, first number plus the second number. Then we get rid of this. Make that go away after you get that first parenthesis. And again, that's just me. First number squared, or first letter squared, minus, multiply a times b, multiply 1/3 times t, plus Second number squared. What is my second number? 1/3. 1/3 times 1/3 is 1/9. And you're done. Okay? So that's the plus. That's when you have a cubed plus b cubed. So let's look at some that have a cubed minus b cubed. And the process is still the exact same. There's just a little bit of a slight difference there in how the formula is written. So that equals, and before this was a plus b, now it's a minus b. And a squared plus ab, which this was a negative, a minus ab when we had the other one, plus b squared. Okay, so again, we're going to do everything the same way. Let's take x cubed minus 8. So first step is to make that a cubed. Okay, so now it's in the right format. Now we're going to write down the first number or letter minus the second one. And that goes away. Don't forget to make that go away. Now, it says take the first letter or number and square it. So we took a and squared it, and that's where that came from. So we're going to take x and square it. Then it says take the two terms over here and multiply them. So the two terms over here and multiply them. Then it says take the last term and square it. The last term 2, and I'm going to square it. Okay, so that gives me x minus 2, x squared plus 2x plus 4. Okay? All right, let us look at number 11. We're going to kind of mix this up a little bit. And I say mix this up, it's really not much of a mix here. So I put the two formulas up there, and let's look at example 10. Okay, we already did that one, but just to look at it again, remember we take the second number and make it into a cube. Then we do the first part. A plus b, y plus 3. Cancel all that out. Square the first, square the first number or term, letter. Subtract these two multiplied. Plus b squared, or plus the second one, squared. 3 squared is 9. Okay, and you're done. Alright, so let's keep practicing some of these and get a better clue of what's happening. We're going to jump to example 12, and that one says 27x cubed plus 125y cubed. Alright, so you may think that we've got everything covered because we have the cube, just like we do here. Problem is, this whole thing has to be cubed. This one, just the x is cubed, here just the y is cubed. We have to make the whole thing cubed. What number times itself 3 times is 27? 3. So 3 cubed x cubed. What number times itself 3 times gives us 125. And since both of these have cubes on them, we can just write it as 3x cubed plus 5y cubed. Meaning we're going to use this example here. And to solve that, or to simplify it, it says take the first two right here and add them. Just the a plus b. So 3x plus 5y. And make that go away, make that go away. Just make all that go away because you don't need anything except that. So it says take the first letter, or the first number, first term, and square it. So the first term is a 3x, square it. Then it says minus, what are we minusing? First term times the second one, 3x times 5y. Remember, you can multiply the numbers and stick the letters on there. And the second part is last term square it. Last term is 5y. Alright, so let's simplify. 3x squared 5 squared and y squared. Okay, so let me check my work here, make sure I got everything right. Oh, I don't. I did make a mistake. I squared the 3, but I didn't square that x there, did I? So that needs to be 9x squared. Everything else looks fine and dandy. Alright, so let's look at example 14 real quick. I think I have time. If I can get all this other stuff erased. Okay, so 14. X to the 6th minus y to the 6th. Okay, so remember, we have to make it in this format. We need cubes up there. So I'm going to go so see what I did? I split the exponent of a 6 into a 2 times 3. So I'd have a cube there and a cube there. Now I could also write it as x cubed squared minus y cubed squared. For this, it's not going to work. It's not going to help me to do it this way, but it doesn't matter if you make it 2 times 3 or 3 times 2. It's still a correct way of writing this here. But since we're dealing with cubes here, a cubed minus b cubed, I need an a and I need a b. So, if you'll notice, this is my a and this is my b, because see, my a and my b are both cubed. What's cubed? X squared. What's cubed? Y squared for my b. So, let's go ahead and use that x squared and y squared as my a and my b. So now I've got an a minus b. So an x squared minus y squared. Get rid of all this. And what does it say? It says I'm going to take my first term, which is an x squared, and I'm going to square it. It's x squared and I'm going to square it, plus my both terms multiplied. Okay, plus b squared, my last term squared. That's my last term and I'm going to square it. So I've got x to the 4th plus x squared y squared plus y to the 4th, and over here I still have my x squared minus y squared. Alright, so you would think we were done, and it would be nice if we were done, but our answer that we got can still be simplified. So we've got this here, and that's an answer, but this is the difference of two squares. So you have to look for that. When I'm done, can I keep simplifying? And so the difference of two squares is the first term plus the second term times the first term minus the second term times x to the 4th plus x squared y squared plus y to the 4th. Alright, so this answer is going to be different than the book's answer for example 14 because they did a different way. Now I should say the answer is the same, it's just going to look different. Okay, so anyway, that is lesson 6.4, and I'm going to do a couple from the problem set for 6.4c video to help you out.